もしやコスモでは。
Cosmo makes me free.
Cosmo AP Luxury Sports.
Well, this is the front suspension and subframe from the Cosmo. And this is the disassembled front subframe and suspension from a second gen S4 RX-7. Can you guess what I'm doing in this episode? So on this episode, I don't know, 39 of my 76 Cosmo restoration, my goal is to replace this with this. Now why would I do this? Lots of reasons. Full of parts that I can't get. Bizarre 4x120 wheel lug pattern, steel control arms, recirculating ball steering, single piston steel calipers. On the contrary, aluminum control arms, standard 5 lug pattern, bearings and bushings that I can actually buy from a parts store, 4 piston aluminum calipers, much larger brake rotors, and of course, rack and peanut steering. Now this is the semi-assembled second gen subframe, and it's very heavy, but unfortunately it's not going to fit. I mean, there's no chance. Everything interferes. Even if I take the oil pan off, you can see that when I lift it up, the steering rack is basically into the engine, and the control arm mounts are so far back that they're in this downturned section of the frame. Now I could shave the top of this off and probably make this rear fit, but that still doesn't fix the oil pan problem. I thought if I could move the steering rack to behind the cross member by taking the spindles and swapping their sides to move the knuckle to the back, but I won't have room to bring the rack and tie rod through the subframe, especially if I have to shave an inch off of the vertical height here. Can you tell I just really wanted to use the RX-7 subframe? Guess it's just not going to happen. Oh, and I also would have had to take about 2 inches out of the center because it's considerably wider than the frame rails of the Cosmo. Of course, that would have necessitated also shortening the tie rod ends. Oh, but you know what? I think I have a solution to this that is relatively clever. But first, I gotta disassemble and clean up this thing. There we go. That one was easy. I have no idea how these are actually supposed to come apart. I'm just kind of guessing. There's a bunch of Mazda mechanics from the 70s, I'm sure, watching me saying, "No, that's not how you do it." Well, I still have a ton of rusty suspension to disassemble, which is going to be pretty time consuming. So why don't I just turn the camera off and get that done. We'll turn it back on when we get to the interesting stuff. Thank you, Mazda, for this bolt. Before I start working with this stuff, I'm just giving it a really quick cleaning so that every time I touch it, my hands Don't look like I've just done something for some guy in a parking lot for more crack. I haven't given up on the RX-7 suspension. I'm just going to combine it with the Cosmo suspension. Since the Cosmo subframe fits the car and doesn't create massive clearance problems, I'll use it, but I will modify the Cosmo control arms to use RX-7 ball joints so I can mount RX-7 spindles, thus RX-7 wheel hubs, RX-7 rotors, RX-7 brakes, and RX-7 bearings. Well, see, this thing isn't really heavy, it's just large and awkward. And that's what she said. But I'm only one person, so just lift it up on the jack. Oh, things go back together so much more easily when they're clean. So as I mentioned, I'm going to use 2nd Gen RX-7 ball joints, which will allow me to mount the 2nd Gen RX-7 spindle. So I can use 2nd Gen RX-7 bearings, 2nd Gen RX-7 5-lug wheel hubs, Second Gen RX-7 brakes. So we'll just put all this together and see about how I'm going to fit it on the car. Well, the evolution in Mazda suspension is pretty clear, but surprisingly a lot of the angles seem to be pretty damn close. And indeed, holding it up and lining it up by eye, I think it's going to work. Just going to pull this off of the car and remove the ball joint. This ball joint requires a special tool to remove. I don't have that tool, so I'm just welding it to a big piece of bar. And hoping the bar will let me unscrew it. Ah, there we go. Look at that. I'll just grind the bar off after the joint's removed. I don't care about damaging the joint because I'm just going to use it for mock-up. To see how well things are going to fit up, I'm going to clamp an RX-7 ball joint into place and mock most of this up. Then we'll take the RX-7 spindle and strut assembly and see how well this whole plan is going to work. Okay, calibrated eyeball test. Look at the angle of the brake rotor and the angle of the strut, as well as the angle of the lower control arm. Stock Cosmo suspension. Now, keeping in mind that I have the top of the strut centered as carefully as I can with a set of vice grips and welding magnets, the old eyeball says that the camber angle of the hub, the caster angle of the strut, and the angle of this lower control arm, which is not really that relevant, is close enough that I think this is going to work. What's going to save me and allow me to correct the suspension geometry is that I can alter this top of the strut tower any way I want to move the top of the strut in any direction to get the proper angles. And really, those RX-7 struts may just be used for mock-up anyway. They might not be the final struts I end up going with because, of course, I'm going to run an air suspension. So they may be replaced with a set of air struts. My plan was to use the RX-7 ball joint and just make a flange to mount it onto the bottom of the control arm. However, the shape of this thing is really weird. So I did a little bit of research, and I think I've come up with a way to turn this into this, but still fit the Cosmo control arm. After about 6 hours of searching the internet for balls, I came up with this. The lower ball joint from an 82 to 87 Mazda 626. Well, let me measure my balls for you so I can show you what I mean. The outside diameter of the threaded portion of the Cosmo ball joint, about 41.2 millimeters. 626 ball joint, about 42.7 millimeters. The RX-7 stud, (18 millimeters). 626 stud, 18 millimeters. So these being press fit joints, once I clearance the threads out of this Cosmo control arm, this joint will press in and allow me to mount the RX-7 spindle. 42.6. Okay, I'm taking 42.6 millimeters as my outer diameter of this ball joint. And my starting ID is just a hair, just a hair over 40 millimeters. Those of you who possess actual machine tools, look away now. This is going to be a long, slow process. Okay, look, I know this is probably not the right way to do this, but it's not like that ball joint has a precision machined outside diameter. It has little fringes that are designed to be crushed into a press fit anyway. So as long as I'm pretty much in the ballpark, it should be okay. But I am doing a few things to try to keep the hole as uniform as possible. I'm always starting the grinder in a different location. I'm moving the stone up and down to keep the wear on the stone even. And I'm using the existing threads as a guide to show how much I've cut. Well, after about 15 minutes of very careful grinding, we're right about where we want to be. 42.3, give or take. Looks like a snug and even fit. There is a slight difference in height between the depth of this hole and the height of the ball joint body. With the retaining snap ring installed, talking about 18.3 millimeters, give or take a few, versus 15.3 RX-5. So I need to make a bit of a washer to take up the slack. Perfect. One custom, weirdly sized washer. There must be a lot of undercoating in there or something. Okay, now she's ready for some ball pressing. Well, lacking a press myself, I had the ball joint pressed in. Thank you, Hanford Tire and Service of London, Ontario. Now the snap ring. Excellent. And that looks to me like a safe and well-retained ball joint. Look at that. And of course, the same work has to be done to the driver's side control arm. One day I will find an inexpensive used laser cutter so I can just cut this stuff out directly. Of course, all this stuff is just mock-up, so I'm not using any grease or torque specs or seals or anything which would just make things gooey and annoying. These are not the correct strut bolts, they're just what I happen to have on hand. Now, before I start figuring out what to do about a steering rack, better put the steering column back into place so I at least have some visual reference. Just pulling some of the fluid lines off the RX-7 rack to make it as easy to handle as possible before I hold it up under the car and check to make sure it's going to fit. I can already tell the RX-7 rack isn't going to work. Story of my life. It's too wide to fit. Well, it's not just the width. That's the problem with using the RX-7 rack. Undoubtedly, some of you have already noticed the fundamental flaw with taking a front steer rack and putting it behind the wheels. I didn't! At least not until later. For now, let's just continue. Off the car, it's easier to see. The RX-7 rack is way too wide because it puts the inner tie rod pivot several inches outboard of the lower control arm pivot. The result of that would be massive amounts of bump steer. Ideally, the inner tie rod pivot and the control arm pivot should be about in line. Now, I don't claim to be a suspension design guru or even play one on TV, but even I know that this is lots of bump steer. This is not much bump steer. Now, when in doubt, measure. I need a rack that's about 58 centimeters pivot to pivot. After many exhaustive hours searching the internet for racks, not all of it porn, I think I found my steering rack. First generation Mazda Miata. Now, the Miata rack is 650 millimeters. Putting the tie rod pivot right about where the inside line of the green tape is. Incidentally, at about 95 millimeters, the strut top mounting bolts of the Cosmo are only a few millimeters off the second gen RX-7. Hint, hint, nudge, nudge. But what I really want is the diagonal here. Close enough. Well, the little bracket that I made is just to hold the strut as centered as, well, it needs to be, so that I can begin mocking up the steering rack. Now we'll just do another one for the passenger side, and then I can start on the steering rack. One brand new 1990 Miata steering rack. Close enough. That fits almost like a glove. Just gotta figure out how to mock this thing into place. And that little jig will help me position my steering rack. Now the idea with this is that I can just hose clamp this in place and then clamp it to the subframe to hold this rack in place while I figure out exactly where it goes. And when I take the subframe off the car to build mounts, it actually stays in place. That's the theory anyway. Okay, and now I can spend the next half an hour or so fiddling with the position of my rack. And I think that's what she said. Well, now it is just a matter of adjusting this thing as straight as possible and centering it. 729. Clamp this sucker in place, and then I can drop the subframe off the car. First half of a steering rack clamp. Okay, so down. Just making a template so I can then cut some sheet metal to give this clamp some sides so that it doesn't flex as I bolt it down to the rack. One steering rack clamp. Now to do the other side. Now the other side is basically the same deal, except the driver's side clamp is a little more ovular. The night after I made that bracket, I was crawling into bed, ready to dream about riding a unicorn naked through the streets of Berlin, except that the unicorn has the body of a giant cat, and the head of the unicorn is the head of Lady Gaga. What? You haven't had that dream before? Weird. Anyway, ready to go off into dreamland, and then it hit me like a bolt of lightning. I was taking a front steer rack and putting it behind the wheels, and in doing so, was about to create a car that when you turn the wheel right, the car would go left. Stupid! But here's why I'm an idiot. On a front steer rack, if you turn the car right, it pushes on the right tie rod, thus pushing the right steering knuckle, pulls on the left tie rod, thus pulls the left steering knuckle. Wheels turn to the right. Now if I take that same rack and put it behind the wheel center line, as I was doing with the Miata rack, I turn right, and once again, it pushes the right tie rod out, which pushes on the steering knuckle, and pulls on the left steering knuckle, and the car turns to the left. So the left-hand drive Miata steering rack goes back to Rock Auto.